everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Maths Chapter 15, Similarity. We will be discussing similarity as a size transformation with examples and solve many questions from exercise 15D. Hope you all are ready. Let's begin. Let us discuss the similarity as a size transformation. Here, consider this figure. I am taking a triangle ABC. This is my triangle ABC. And a point P is considered which lies outside the triangle ABC. From this point P, here a line is drawn which meets A. Okay, from point P to A. We have a dotted line. This length is PA. On extending this line, it meets at a point A dash. We are marking a point A dash here. One condition is this length is taken and twice the length will be PA dash. PA dash will be equal to 2 times PA. In such a way, we have to extend PA to a point A dash. Okay. Similarly, when you join point P and B, we get length PB. This PB is extended to twice PB to a point B dash. PB dash is equal to 2 times PB. Similarly, from point P to C, we are joining and extending it to C dash such that PC dash will be equal to 2 times PC. Okay. Now, on joining these points A dash, B dash and C dash, we get a new triangle. When you look at this triangle, we understand that this triangle is an enlarged version of the smaller triangle. When you consider the corresponding sides, corresponding to AB, here we have A dash, B dash. Corresponding to BC, here we have B dash, C dash. And corresponding to AC, here we have A dash, C dash. So, this is the triangle, the enlarged triangle. Okay. Now, when you compare the corresponding sides, you will be getting A dash, B dash will be equal to 2 times AB. B dash, C dash will be equal to 2 times BC. And A dash, C dash will be equal to 2 times AC. Here, the triangle has become 2 times. All the corresponding sides. The side AB, 2 times AB is A dash, B dash. Now, this type of a transformation, here what is happening? Enlarging is happening. That too, 2 times. This 2 is called the scale factor. Okay, we call this 2 as scale factor. Here, scale factor is 2 and scale factor is represented with the letter K. So, this is the case. Here, the enlarging of triangle has happened. That is, A dash, B dash, C dash is an enlarged version of triangle ABC. Okay, this is the actual triangle or the object. We consider this as object and this is the taken as the image, the enlarged version. Okay, now consider this figure. Here we have a big triangle ABC. This is a big triangle ABC. First, we are taking. And a point P is considered which is taken outside the triangle ABC. From P, we are drawing a line to A. So, this is the line. And half the length we are marking a point A dash. So, this is A dash. So, A dash. When you take P A dash, it will be equal to half of PA. Okay, half the length PA. At that point, we are marking A dash. Similarly, when you take PB dash, it will be equal to half of PB and PC dash will be equal to half of PC. Okay, just the reverse process is happening here. There we are enlarging. Here we are reducing. Okay, so here the reduction has happened. We get points A dash, B dash and C dash. On joining these points A dash, B dash and C dash, we get a smaller triangle. This is a smaller triangle. When you compare these triangles, they will be similar. These triangles, triangle A dash, B dash, C dash will be similar to triangle ABC. Okay, then what is that? When you consider the corresponding sides, corresponding to A dash, B dash, here we have AB, corresponding to BC we have B dash, C dash, corresponding to AC we have A dash, C dash. Now what about the length of these corresponding sides? We will be having A dash, B dash has reduced by half, that is half of AB. B dash, C dash has reduced by half of BC. And A dash, C dash will be equal to half of AC. So this type of a reduction has happened. Here the scale factor is equal to half. Okay, in this case, the scale factor is equal to half. Here the scale factor is equal to 2. Now this point P is called the center of enlargement. In this case, P is the center of enlargement. With respect to what the enlarging is happening, P is center of enlargement. Then what about this case? Here we have a P. With respect to P, the reduction has happened. The shrinking has happened. Yes. So this P here is called the center of reduction. So the similarity as a size transformation, either an enlarging is happening, then we will be getting a similar triangle which is a bigger version of the given triangle, or a reduction is happening. That is, the bigger triangle is reduced to or shrink to a smaller one which is also similar. So what is similarity transformation? Then we can define similarity transformation. In a similarity transformation, a given figure is enlarged or reduced. Here enlarging is happening and here reduction is happening. By a scale factor, here it becomes 2 times. Here it is becoming half. This is what the scale factor, K, such that the resulting figure is called the image. Here A dash, B dash, C dash is the image, is similar to the given figure. Given figure is ABC. It is called the object or the pre-image. Understood? Let us see the application of similarity as a size transformation. Here, how to apply to maps and models. You can find the figure here. What is this? Eiffel Tower. All of us know. Now, when you see the Eiffel Tower and you want to draw the picture in your book, what will you do? You will have to reduce its size. We cannot draw a picture that is of actual size of Eiffel Tower. Can we do that? No, right? We cannot do. If you see a big board and you are asked to draw the picture of the board on a paper, what you will do? You will reduce the size. The same thing we are going to do here. So, on mapping it or drawing on a map, drawing on a paper, what we do is we will be reducing the size of the object. Yes? We have to reduce the size of object. Here we have an Eiffel Tower, we will be reducing the size. Reducing the size in the sense, we will reduce the height, we will reduce the width, we will reduce the breadth, everything will be reduced. Okay. Now, if I am taking a plot, okay, here I have a plot of length 100 meter and breadth 50 meter. I am asking you to draw this on a paper. Okay. For that, what can be done? I am going to reduce by 100. Okay, I am going to reduce the size by 100. When I reduce the size by 100, it means I have to reduce the length and I have to reduce the breadth. I will be getting 1 meter and 0.5 meter here. Can I draw this on your... Can you draw this in your notebook? No, right? 1 meter and 0.5 meter cannot be drawn on a notebook. But I can draw it on my board. So, 1 meter, 0.5 meter length I can draw on my board. So, this box I can draw on my board. Now, you have to draw it. For that, let me reduce further. Reduce by 1000. When you reduce by 1000, what do we get? We will be getting a smaller figure. Yes. So, the length will be 0.1 meter and the breadth will reduce to 0.05 meter. 0.1 meter and 0.05 meter. Now, you can draw it on your notebook, right? Yes. So, we have reduced it. So, reducing, there is a factor in which I am reducing this. Here, we had 100 meters and 100 meters I have reduced to 0.1 meter. Yes, 100 meter is the real ground. It is called the real ground, the actual one. Actual plot length was 100 meters. It has reduced. That is what is on the map, what is on the paper, what is on your notebook. What is the length? We have 0.1 meter. Okay, this is what we get on the map. That is 100 meter we have reduced to 0.1 meter. When 100 meter is reduced to 0.1 meter, we have reduced 50 meter to 0.05 meter. Now there is a factor in which the reduction has happened. Yes, here the factor is 1 by 1000. 1 by 1000 is the factor. That is 100 meter into 1 by 1000. We get 0.1 meter. Similarly, 50 meter into 1 by 1000, we get 0.05 meter. This is the length and this is the breadth. Now we are able to draw in the book. Okay, so there is a reduction happened here. So in order to plot on a map or on a paper, we have to reduce the size. In which factor the reduction has happened? This factor we call the scale factor. Therefore, we have scale factor which we have discussed in the previous slide. Scale factor is represented by letter K, and here the scale factor of reduction is equal to 1 by 1000. Scale factor of reduction is equal to 1 by 1000. Understood? Now, scale factor will be equal to the length on map divided by actual length. Okay, the length that is measured on map divided by actual length will give you the scale factor. What is the length on map? In this case, the length on map is 0.1 divided by actual length. What is the actual length in this case? Here the actual length is 100 meters. 100 meters. This will be equal to 1 by 1000, right? On removing the decimal, that is multiplying numerator and denominator with 10, we will be getting 1 by 1000. So, this is the K factor. So, the scale factor is equal to length on map divided by the actual length. Clear? Got the idea? So, we can say that map is the scaled down image of real ground. We are reducing it and drawing on a notebook, or reducing it and representing it as a map. Understood? Now, scale factor we have discussed. Scale factor K is equal to the length on map divided by the actual length. Okay. Here, length of map divided by actual length gives us the scale factor K. Okay. Then what is the length on map? Length on map will be equal to, length on map will be equal to K into actual length. Okay. Let us consider a triangle. This is my triangle ABC. Okay. I am reducing this triangle with a scale factor K. What happens then? Here I am taking the side as A. Length of side AB is A. Length of side BC is B. And length of side AC is C. Okay. Now I am reducing it to a smaller triangle. This is my new triangle. A dash, B dash, C dash. The length will have changed. It will be reduced by a factor of K. That is, it becomes KA. A dash, B dash will be KA. B dash C dash will be equal to KB, and A dash C dash will be equal to KC. Yes, so the length on map, this is reduced in order to put this figure on a map. So when you get the length on map, here the length on map is KA, right? How we are getting it? Actual length A into the scale factor K. Now when it comes to area, we know, for example, an area of rectangle is considered. Area of rectangle will be equal to length into breadth, right? Here, area on map or model. Model means if you are seeing that Eiffel Tower's case. If you want to draw the picture of Eiffel Tower, what will you take the length on map? Length on map will be k times the actual length, and it is a reduction process. So here either it can be a figure, a 2D image, or a model, a 3D one. When you put it on a notebook or put it on a paper, what is happening? There is a reduction happening. It will be equal to k square times actual area. Consider, I am taking a rectangle. This rectangle has one side equal to A and the other side equal to B. Okay, we know area of a rectangle, area is equal to, area of rectangle is equal to length into breadth. Here we have A and B. Therefore, A into B. Okay, I am reducing this. Reducing with a scale factor K. I will be getting a smaller rectangle. Okay, for this smaller rectangle, we need to find the length and breadth. What will happen? Length will be reducing with the factor of K. With the factor of K, which is the scale factor. And breadth also will be reducing with the factor of K. Which means the area of smaller rectangle will be again equal to length into breadth. Here length will be equal to K into A. What about breadth? Breadth will be equal to KB. Okay. K into K can be taken out. K into K is K square. Then we have A into B. What is A into B? A into B is the area of the actual rectangle. Therefore, area on map. We can represent it as area on map. Area on map will be equal to K square into actual area. So this is how you will be getting K square. You should not get confused. Understood? The length is reducing by K. Breadth is also reducing by K. Therefore, we are getting K square here. Next, the third one, volume of model will be equal to K cube into actual volume. Volume is only in the case of 3D. Here, let us consider a cuboid. This is a cuboid. A is its length, breadth is B, and height is equal to C. Now what happens? I am going to reduce this. Reduce to a smaller cuboid in order to put it on a notebook or a paper. What happens? Length is reduced, breadth is reduced, and height is reduced. Here what is the volume for the actual cuboid? Volume of cuboid we know is equal to length into breadth into height. Here A into B into C. Here for the smaller cuboid or the reduced cuboid, volume. To find volume, what happens to length? Length will be equal to K into A. It will reduce by K factor, and that is K into A. What about breadth? Breadth will become equal to K into B, and height will be equal to K into C. Now what is the volume then? Volume of the model made will be equal to length into breadth into height. In this case, Ka into Kb into Kc. K into K into K, we get K cube into A into B into C. We have ABC. ABC is the volume of the actual cuboid. Therefore, volume of model will be equal to K cube into volume of actual object. K cube into volume of actual object. Understood how this K cube came? Because length is reduced, breadth is reduced, and height is reduced by a factor K. Okay. Now, depending on the scale factor, we can say what the transformation has happened. That is, if K is greater than 1, then it is enlargement. Remember the first slide, K greater than 1. In that case, we had K is equal to 2. That is enlarging. Length is increasing, breadth is increasing, height is increasing. That is the case. Enlargement is a case when K is greater than 1. When k is less than 1, in that case we will be having reduction. Just take this example. K less than 1 means anyway the value of k will be less than 1. Only then k into a will be less than a. Okay, Ka should be less than A because there is reduction happening in this case. Kb should be less than B. This is again a reduction. Kc should be less than C. So for this to happen, what we'll be getting? Ka less than A means K less than A by A. Cancelling we get 1. That is how in the case of reduction, K will be less than 1. And if K is equal to 1, if K is equal to 1, it is an identity transformation. The two triangles, if you are taking triangles, the two triangles will be similar. All the sides, all the corresponding sides will be equal. Clear with these concepts? We'll be doing more examples to understand further. Let us take an example. A model of a ship is made to a scale of 1:200. If the length of the model is 4 meters, calculate the length of the ship. Here, it is clear that the scale factor is equal to 1/200. Okay, we have scale factor K is equal to length of model divided by length of object. Yes, we have studied this. Now, what is length of model then? Length of model will be equal to K into, that is a scale factor into length of the object. Here the object is a ship, length of ship. What is a given quantity? Given that the length of model is 4 meters. Length of model is equal to 4 meters. Okay, then we can find the length of ship. Yes, length of ship we need to find. How to find the length of ship? We have length of model 4 meters is equal to K. K is 1/200. 1/200 into the length of ship. Okay, 4 meters is equal to 1/200 into length of ship. Then length of ship is equal to 4 meters into 200 is taken to the opposite side. 200. What is 4 meters into 200? 800 meters. So this is our final answer. That is the length of ship will be equal to 800 meters. Simple, right? Second example. The scale of a map is 1:50,000. In the map, a triangular plot ABC of land has the following dimensions. Dimensions are given. ABC equal to 2 cm, BC is equal to 3.5 cm and angle ABC is equal to 90 degree. From this, it is clear that the figure which is mapped is a right triangular plot. ABC, this angle is 90 degree. AB dimensions, AB is given, AB is 2 cm and BC is equal to 3.5 cm. This is 2 cm and this is 3.5 cm. Okay, this is how it is mapped on a paper or a board. Now, we have to calculate the actual length of side BC in kilometer of the land, and the second, the area of the plot in square kilometer. What is given? Given scale factor K is equal to, scale factor is represented by letter K and that is given, which is 1/50,000. Okay. Now we have length on map BC will be equal to K into actual length BC. Yes, we have a formula. Length on map will be equal to scale factor into the actual length BC. Here, length on the map is given, which is 3.5 cm. 3.5 is equal to, what is K? K is 1/50,000 into actual length BC. This is what we have to find. We'll put it as BC. Now, what is BC then? BC will be equal to 3.5 into 50 50,000. Okay. 50,000 into 3.5, we get 1,75,000. This is in centimeters. We have to convert it into kilometers because in the question it is mentioned to find the side BC, actual length of side BC in kilometers. How to convert to kilometers? We are having 1 kilometer is equal to 1000 meters and 1 meter is equal to 100 centimeter. If 1 meter is equal to 100 centimeter, then 1000 meter will be equal to 1000 into 100 centimeter. That is 1 kilometer is equal to 1000 into 100 centimeter. How many zeros we have? 1, 2, 3, 4, 5. 5 zeros. 3, 4, 5 centimeter. That is 1 kilometer is equal to 1 lakh centimeter. Then what is 1 centimeter? 1 centimeter will be equal to 1 by 1 lakh kilometer. 1 by 1 lakh kilometer. Here we have 1,75,000 centimeter. That is equal to 1,75,000 divided by 1 lakh. So how many decimal places when you divide by 1 lakh? We have 1, 2, 3, 4, 5. 5 zeros. So you have to move 5 decimal points. That is 1, 2, 3, 4, 5. So here you will be putting the point. That is 1.75 kilometers. Okay. So the actual length BC is equal to 1.75 kilometer. 1.75 kilometer. Okay. Understood this? Next is to find the area. We have area on map is equal to K square into actual area. Yes, K square into actual area. Okay. Now what is the area on map? We have to find area on map. Area is equal to, this is a right triangle. For a triangle, how to find area? Base, height, we need to know. So, area of triangle we have half into base into height. For this triangle, base is BC and height is AB. That is half into base BC into height AB. These are the lengths on map. Equal to half into BC is 3.5 and height AB is 2 centimeter. 2 gets cancelled. Then we get area on map is equal to 3.5. What is the unit? Unit is centimeter square. Okay. 3.5 centimeter square. Now, we can find the actual area. Actual area is equal to area on map divided by K square. Okay. So, here we have determined the area on map which is 3.5. 3.5 is equal to K square. What is K? K is equal to 1 by 50,000 whole square into actual area. Actual area. Okay. So, to get the actual area, what can be done? Actual area is equal to taking this 50,000 square to the opposite side. 3.5 into 50,000 square. Okay. When you calculate this, you will be getting 0.875 kilometer square. So, first, when you find 50,000 square and multiply with 3.5, you will be getting an answer which is in centimeter square. So, in order to convert that centimeter square into kilometer square, what can be done? We have 1 centimeter is equal to 1 by 1 lakh kilometer. Therefore, 1 centimeter square. What about 1 centimeter square? 1 centimeter square will be equal to 1 by 1 lakh square kilometer square. Okay. So, you have to divide with this in order to get this value. You can do, right? Should I do? No, you will be able to do. So this is your final answer. 0.875 kilometer square. This is the area in kilometer square. Next, example 3. A rectangular tank has length 4 meter, width 3 meter and capacity 30 meter cube. A small model of the tank is made with capacity 240 centimeter cube. Find the first question, the dimension of the model, and the second, the ratio between the total surface area of the tank and its model. Now, what are the given quantities? Here, in the rectangular tank, the length of the tank is given. For tank, length is equal to 4 meter. This is the original tank. Then, width is given. Width is equal to 3 meter. Capacity. Capacity is the volume. Volume is equal to 30 meter cube. Okay, we know volume of the tank will be equal to length into breadth into height. Okay, here breadth is same as width, which is equal to the volume, which means 4 into width or the breadth is 3 meter, 3 into height we don't know, we put it as h, is equal to the volume given 30. Then what is h? H will be equal to 30 divided by 4 into 3. 3 and 30 can be cancelled. We get 10. 10 by 4 is equal to 2.5 meter. Therefore, height h is equal to 2.5 meter. Okay. We got the length, breadth and height of the original tank. Also, we know the volume of the tank. What else is given? We are making a smaller model. Volume of model is given. Volume of model tank is equal to 240 centimeter cube. It is given in centimeter cube. We have to find the dimensions of the model. We know the dimensions of the original tank. We are going to find the dimensions of model. In order to find the dimension of model, first we need to find the scale factor. How to find scale factor in this case? We have volume of model is equal to k cube into, in this case the object is a tank. Therefore, k cube into volume of tank. Okay, volume of model is given, which is 240 centimeter cube is equal to k cube into volume of tank. Volume of tank also is known, that is 30 meter square. Now, we have 1 meter is equal to 100 centimeter. Then what is 1 meter cube? 1 meter cube will be equal to 100 into 100 into 100 centimeter cube. We are converting to centimeter cube. Here we have 30 as the volume. 30 into 100 into 100 into 100 centimeter cube. Okay. Now, what is k cube then? K cube will be equal to 240 divided by 30 into 100 into 100 into 100. 0, 0 gets cancelled. Now, here we have 3 and 24 can be cancelled, which is 8. Okay. What is 100 divided by 8? How much do we get when you divide 100 by 8? 100 divided by 8 is equal to 1 point. What is 100 divided by 8? When you do 100 divided by 8, we'll be getting 12.5. Okay. So, here 8 divided by 100, I am taking this part, 8 divided by 100. 8 divided by 100 will be equal to 1 by 12.5. 1 by 12.5 into 100 into 100, which is equal to, I am removing these decimals, I will be getting 1 by, here we have 1, 2, 3, 4. 1, 2, 5 and 3 zeros. Okay, 1, 2, 5 and 3 zeros. So we are getting k cube is equal to 1 by 1, 2, 5, 0, 0, 0. Okay. Here to find k, we have to take the cube root of 1 by 125 0, 0, 0. What is the cube root? If you take 50, 50 into 50 into 50, what do we get? 5 into 5 into 5 is 125, 0, 0, 0. So, 1,25,000 cube root when taken, we will be getting 50. Okay. So, k is equal to 1 by 50. K is equal to 1 by 50. Now, we can find the length of the model, breadth of the model and height of the model. We have length of model is equal to k into length of tank, that is the original length. Yes, put the values. Here we have k 1 by 50 into what is the length of tank? Length of tank is given, which is 4 meter. 4 meter. So, I am converting this 4 meter to centimeter. We get 400 divided by 50 equal to, zeros gets cancelled, 40 by 5 is 8. What is the unit? Centimeters. Okay. Length of the model is 8 centimeter. Next, we will find the width of model. Width of model will be equal to k into width of tank. Actual width. Okay. Here we have k equal to 1 by 50 into, what is the width of tank? Width of tank is given in the question, which is 3. Okay. This is 3 meters. We have to convert it into centimeters. Equal to 300 centimeter divided by 50. Cancelling zeros, we get 6 centimeter as the width of the model. Now to find the height of model. Height of model is equal to, again, k into height of tank. Height of tank we have determined, which is 2.5 meter. K is 1 by 50 into, we have height 2.5 meter, which is 250 centimeter. Cancelling zeros, we get 5 centimeter as the height of the model. Therefore, length L is equal to 8 centimeter. Width B is equal to 6 centimeter. And height h is equal to 5 centimeter, which are the required dimensions of the model. Okay. Next, we have to find the ratio between the total surface area of the tank and its model. We have total surface area. Area of model is equal to k square into area of tank. That is the actual area. Here we need to find the ratio between the total surface area of the tank. Tank should come in the numerator. Area of tank divided by area of model will be equal to, I am taking this area of model to the opposite side. K square will come to the opposite side denominator. That is 1 by k square. Okay. We know the value of k. Yes. So, area of tank divided by area of model is equal to 1 by 50 whole square. Taking the reciprocal and multiplying, we get 1 into 50 by 1 whole square. What is 50 square? 50 square is equal to 2500. Okay. So, we are getting 2500 and the denominator we have 1. The ratio is 2500 is to 1. This is the required ratio. Okay. The ratio between the area of tank and area of the model is equal to 2500 is to 1. Clear? Let us now do more problems from exercise 15D. Here we have the first problem, question 1 of exercise 15D. A triangle ABC has been enlarged by a scale factor m is equal to 2.5 to the triangle A dash B dash C dash. Calculate the first part, the length of AB if A dash B dash is equal to 6 centimeter, and the second, the length of C dash A dash if CA is equal to 4 centimeter. Here we have a triangle. This is my triangle ABC, which is enlarged to triangle A dash B dash C dash. The scale factor is given. Scale factor M is equal to 2.5. Okay, so the first question we need to find the length of AB. AB is the side of the original triangle and A dash, B dash, C dash is the enlarged triangle. We will be having length of model is equal to scale factor M into length of object. Here what is the model and object? Object is the original one and model is the new one. Okay. So here we need to find the length of AB. Length of AB means the original one, which means the length of object. Therefore, we will be having length of model as A dash B dash is equal to M into length of object is AB. Okay. We have the value A dash B dash. A dash B dash is equal to 6 centimeter. Also we have M. M is 2.5. Then AB will be equal to A dash B dash divided by M. A dash B dash is 6 centimeter. 6 divided by M is 2.5. Okay. So I am going to multiply numerator and denominator with 10 in order to remove the decimal. 60 divided by 25. On cancelling, 5 into 5 is 25. 5 into 12 is 60. 12 divided by 5 and that is equal to 2.4 centimeter. So 2.4 centimeter is the length of AB. 2.4 centimeter. Now the second one. Second question, we need to find the length of C dash A dash. C dash A dash is the length of model and CA, the length of object. Length of side of object is given, which is 4 centimeter. Here object is the original triangle and model is the new enlarged triangle. Okay. So to find the second length of C dash A dash, we will be having C dash A dash is equal to M into CA. What is the value of CA? CA is given, which is 4 centimeter. Then C dash A dash will be equal to M into CA. M is equal to 2.5. 2.5 into CA, which is 4. Okay. We know 25 into 4 is 100. Therefore, 2.5 into 4 will be equal to 10. 10 centimeter is your answer. We got the values. AB is equal to 2.4 centimeter and C dash A dash is equal to 10 centimeter. Next, problem number 2, question 2 of exercise 15D. A triangle LMN has been reduced by scale factor 0.8 to the triangle L dash M dash N dash. Calculate the length of M dash N dash if MN is equal to 8 centimeter and the length of LM if L dash M dash is equal to 5.4 centimeter. Here we had a triangle LMN which is reduced to a smaller triangle L dash M dash N dash. Okay. Then the scale factor is given. Scale factor K is equal to 0.8. Okay. Here the length of M dash N dash we need to find if Mn is equal to 8 centimeter. Mn is this. This is 8 centimeter. We need to find M dash N dash in the first question. How to find? We have length of model divided by length of object is equal to scale factor. Here the length of model is the reduced one and the length of object is the original triangle. Therefore, the length of model, that is, we have to find M dash N dash. M dash N dash divided by length of object. Here the given length which is Mn. mn is equal to k. The value of k is 0.8. Scale factor k is 0.8. Therefore, m dash n dash will be equal to 0.8 into mn, that is 0.8 into value of mn is equal to 8 centimeter. 8, that is 8 into 8, 64. We have a decimal 6.4. The unit is centimeter. We got the length m dash n dash. This part m dash n dash is equal to 6.4 centimeter. Now the second, we need to find the length of LM. LM is this part. If L dash M dash is 5.4 centimeter. Okay, how to find? We'll be having L dash M dash divided by LM. Length of model divided by length of object is equal to scale factor k. K is here 0.8. Therefore, we have the value L dash M dash, which is 5.4 divided by LM is equal to 0.8, which implies LM is equal to, cross multiplying, we get LM is equal to 5.4 divided by 0.8, which is 54 divided by 8, and that is equal to 6.75 centimeter. So, 6.75 centimeter is the length LM, 6.75 centimeter. Okay. Next, problem number 3, question 3 of exercise 15D. A triangle ABC is enlarged about the point O as center of enlargement and the scale factor is 3. Find, first question, A dash B dash if AB is equal to 4 centimeter, BC if B dash C dash is equal to 15 centimeter, OA if OA dash is equal to 6 centimeter, OC dash if OC is equal to 21 centimeter. Also, state the values of A, OB dash by OB, and second, C dash A dash divided by CA. Here we have two triangles. The first triangle is enlarged to the second triangle with a scale factor of 3. So, this is my first triangle A, B, C. Okay, it is enlarged to a triangle A dash, B dash, C dash. Given the center of enlargement is O. Here I have O. Okay. So, this length is OA and extending we get OA dash. This length is OC and we extend it to get OC dash. This is OB. On extending we get OB dash. Now, here given that the scale factor is equal to 3. Okay, scale factor M is equal to 3. For the first question, we need to find A dash B dash if AB is equal to 4 centimeter. AB is this part. If it is equal to 4 centimeter, what is A dash B dash? We have A dash B dash is equal to scale factor M into AB. AB is the side of the original triangle and A dash B dash is the side of the enlarged triangle. Now, in order to find A dash B dash, we can put the values. A dash B dash will be equal to M is equal to 3 and AB is equal to 4 centimeter. 3 into 4 centimeter, which is 12 centimeter. We get A dash B dash. A dash B dash is equal to, this length is equal to 12 centimeter. Okay. Now the second one, we have to find BC if B dash C dash is equal to 15 centimeter. B dash C dash is this portion. It is given 15 centimeter. If this is 15 centimeter, how to find BC? We have B dash C dash is equal to scale factor M into BC. Okay. Now we have the value of B dash C dash. Therefore, we will be having BC is equal to B dash C dash divided by M. Put the values. B dash C dash is 15 and M is equal to 3. 15 divided by 3 is 5 centimeter. So, 5 centimeter is the length of BC. Now the third one, we have to find OA if OA dash is equal to 6 centimeter. OA is this length given OA dash. This length is equal to 6 centimeter. So if you consider triangles, if I consider a triangle OBA and OB dash A dash, they will be similar because this small triangle is enlarged with the center of enlargement O. Okay. Therefore, the ratio of OA dash divided by OA will be equal to the scale factor. Scale factor here it is 3. Therefore, it is given that OA dash is equal to 6 centimeter. Then OA is equal to OA dash divided by 3, and that is 6 by 3 equal to 2 centimeter. Okay. OA, this length is equal to 2 centimeter. Now the fourth one, we have to find OC dash if OC is equal to, OC is this length, OC is 21 centimeter. OC dash will be equal to M into OC. Okay. So OC dash is equal to M is 3 and OC is equal to 21 centimeter. That is 3 into 21 centimeter, which is 63 centimeter. OC dash is equal to 63 centimeter. Clear? Now we need to find the values of OB dash by OB and C dash A dash divided by CA. OB dash by OB. OB dash divided by OB. Here if you consider, we know that ABC and A dash, B dash, C dash are similar triangles. With this, we will be getting OAB and OA dash, B dash are also similar triangles. So the corresponding sides of, the ratio of the corresponding sides of similar triangles will be getting equal to the scale factor in this case. Here OB dash divided by OB will be equal to the scale factor, which is 3, because the enlargement is in units of 3. Okay. Now the second one, B part, C dash A dash divided by CA. Again considering the triangles A dash, B dash, C dash. Triangle A dash, B dash, C dash and triangle ABC. Since they are similar triangles, triangle A dash, B dash, C dash similar to triangle ABC will be having A dash, B dash divided by AB equal to B dash, C dash divided by BC equal to A dash, C dash divided by AC. Okay. So we need to find C dash A dash divided by CA. Now what is this ratio equal to? This will be equal to the scale factor 3. Yes, because this A dash B dash divided by AB will be equal to 3. In the first question, we have said this. Okay. Now we are having C dash A dash divided by CA is also equal to 3. Okay. Let's move on to the next problem. Problem number 4, question 5 of exercise 15D. The dimensions of the model of a multi-story building are 1.2 meter by 75 centimeter by 2 meter. If the scale factor is 1:30, find the actual dimensions of the building. We need to find the actual dimensions of building. So here, given the dimensions of model. Dimensions of model is equal to 1.2 meter by 75 centimeter by 2 meter, which is equal to 1.2 meter. We'll convert the 75 centimeter in units of meter. That is 0.75 meter by 2 meter. Okay. We need to find the dimensions of actual building. Dimensions of actual building. What else is given? The scale factor is given. Scale factor is equal to, here the scale factor is 1:30, which is 1 by 30. We know the length of the model divided by length of object will be equal to scale factor. In this case, dimension of model by dimension of actual building will be equal to the scale factor, which is 1 by 30. Now we need to find the dimension of the actual building. Actual dimension will be equal to actual dimension taken here. Then we have dimension of model and 1 by 30. This 1 by 30, 30 goes here. 30 into dimension of model. 30 into dimensions of model. Okay. So here we have the length. Let us take length is 1.2 meter, breadth is 0.75 meter and the height is 2 meter. That is, when you multiply 30, all of this should be multiplied separately. That is 30 into 1.2 meter by 0.75 meter by 2 meter. 30 into 1.2 meter, we get 36 meter by 30 into 0.75 meter, we get 22.5 meter and 30 into 2 meter, we get 60 meter. So these are the dimensions of the actual building. Actual dimensions is equal to 36 meter by 22.5 meter by 60 meter. Understood? So the length, breadth and height of the actual buildings are 36 meter, 22.5 meter and 60 meter. Next, problem number 5, question 6 of exercise 15E. On a map drawn to a scale of 1:250,000, a triangular plot of land has the following measurements. AB is equal to 3 cm, BC is equal to 4 cm and angle ABC is equal to 90 degree. Calculate the first question, the actual lengths of AB and BC in kilometer. Second one, the area of the plot in square kilometer. Here we have a triangular plot and it is given that angle ABC is equal to 90 degree, which means it is a right triangle. ABC, this is 90 degree. Length AB is equal to 3 cm and BC is equal to 4 cm. Okay, AB is 3 cm and BC is 4 cm. Now, given that the scale factor K is equal to 1 by 250,000. Okay, in the first part we need to find the actual lengths of AB and BC in kilometers. We know that 1 kilometer is 1000 meter and 1 meter is 100 centimeter. Therefore, we will be having 1 kilometer is equal to 1000 into 100 centimeters. That is 1,000,000 centimeter. This is what 1 kilometer is. You have to remember this conversions of units and all. Now, in order to find the actual length of AB, we have length of AB on map divided by actual length AB equal to the scale factor K. We have studied that the length of model divided by the length of original will be equal to scale factor. Here the length of AB on map, we know. What is length of AB on map? It is 3 cm. 3 divided by actual length. Actual length AB will be equal to the scale factor and here the scale factor is 1 by 250,000. Okay, then what is AB? On cross multiplying, we get AB is equal to 3 into 250,000. 3 into 250,000 is 7,50,000. We get 7,50,000. So this 7,50,000 is in centimeter. We need the values in kilometer. How to convert to kilometer? We have 1 kilometer is equal to 10 raised to 1, 2, 3, 4, 5. 10 raised to 5 centimeter. Yes. Then what is 1 centimeter? 1 centimeter will be equal to 1 by 10 raised to 5 kilometer. Yes. Here we have 7,50,000 centimeter. We have to convert the centimeters now into kilometers. That is equal to 7,50,000 into, we have 1 centimeter equal to 1 by 10 raised to 5 kilometers. That is 1 by 10 raised to 5 kilometers. Now here we have 5 zeros. We can cancel 1, 2, 3, 4. 4 zeros can be cancelled. And the remaining will be having 75 divided by 10. And that is equal to 7.5 kilometer. Okay, 7.5 kilometer is the length of AB. Similarly, we need to find the length BC. How to find BC? We'll be having length BC on map divided by actual BC is equal to the scale factor. Here the scale factor is 1 by 2,50,000. Put the values to get actual BC. BC will be equal to 2,50,000 into the length BC on map. What is the length BC on map? It is equal to 4 centimeter. 4 centimeter, which is equal to, we get 10 lakhs. Okay, we get 10 lakhs. Now we have to convert this 10 lakh centimeter into kilometers. How to convert? 10 lakh into 1 by 10 raised to 5 kilometer. 10 raised to 5 has 5 zeros. 1, 2, 3, 4, 5. We can cancel 5 zeros. And this 10 raised to 5, that is, answer will be 10 kilometer. BC will be equal to 10 kilometer. Therefore, we got AB is equal to 7.5 kilometer and BC is equal to 10 kilometer. We need to find the area of the plot in square kilometer. Second question, area. This is a right triangle. For right triangle, how to find area? Area is equal to half into base into height. Here the base is BC and height is AB. So, for the new triangle, that is the original triangle or the actual triangle, we have BC is equal to 10 kilometer, which is the base, and AB is equal to 7.5 kilometer height. Just put the values, we get 1 by 2 into 7.5 into 10. 7.5 into 10 is 75 divided by 2, which is equal to 37.5. What about the unit? Unit will be kilometer square or 37.5 square kilometer. Okay, kilometer into kilometer, we get kilometer square, or you can present it as square kilometers. Understood this? Here we have the last problem for today, problem number 6, question 7 of exercise 15D. A model of a ship is made to a scale 1:300. First thing we have to find the length of the ship if the length of the model of the ship is 2 meter. Second, the area of the deck of the ship is given, which is 1,80,000 meter square. We have to calculate the area of the deck of the model. And the third question, we have to find the volume. The volume of model of is given, that is 6.5 meter cube. We have to calculate the volume of ship. We have the scale factor K. Scale factor K is equal to 1 by 300. Okay. In the first question, we need to find the length of ship. We have length of model. Length of model is equal to K into length of ship. Okay, or the actual length. Here we have a ship. The object is ship. Therefore, the length of ship. Now, what is the length of model? Length of model is given, which is 2 meters. 2 meter is equal to K is 1 by 300 into length of ship. Now, how to find the length of ship? Length of ship is equal to 2 meter into this 300 can be taken to the opposite side. 300, which is equal to 2 meter into 300 is 600 meters. Okay. Therefore, the length of ship is equal to 600 meters. Now, the second one, area of deck of ship is given, which is 1,80,000 meter square. We have area of model is equal to K square into area of ship. Okay, the area of the model is equal to K square into area of the deck of ship. Now, given the value of the area of deck of the ship, that is 1,80,000 meter square, we have to find the area of deck of model. Area of model is equal to, what is K square? We have K 1 by 300. Therefore, K square is 1 by 300 whole square. And area of ship is 1,80,000 meter square. 1,80,000 meter square. Okay. Now, area of model will be equal to 1,80,000 divided by 300 square. 300 square. 3 square is 9. 0, 0, 0, 0. 1,80,000 divided by 90,000 will be equal to 2 and the unit is meter square. Okay. So, the area of model is equal to 2 meter square. Area of the deck of model will be equal to 2 meter square. Now, the third part, the volume of model is 6.5 meter cube. Volume of model is equal to 6.5 meter cube. We have to calculate the volume of ship. Volume of ship. Okay. We have volume of model is equal to K cube into volume of ship. Yes. What is volume of model? Volume of model is 6.5 equal to K cube. K is 1 by 300. Therefore, K cube is 1 by 300 whole cube into volume of ship. Volume of ship. Okay. Then volume of ship will be equal to 6.5 into 300 cube. So, this 300 cube is taken to the opposite side numerator. 6.5 into, what is 300 cube? 3 cube we know is equal to 27. Then put the zeros. We'll be having 6 zeros. Okay. Now, when you calculate this value, the final answer will be 175550 and the unit is meter cube. So, this is the volume of the ship, the actual volume of ship. Clear? Understood this question? That's all for today. In today's class, we have discussed similarity as size transformation and its applications to maps and models. We have solved many questions from exercise 15D. Hope you all enjoyed this session. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.